Hello everyone and welcome to the lecture on Amazon Redshift. So this lecture will contain all these topics. Two versions or mode of Amazon Redshift. What is Amazon Redshift? Amazon Redshift Serverless. Amazon Redshift Provision Clusters Overview. Amazon Redshift Provision Cluster Database. Amazon Redshift Serverless Key Concepts. Understanding Amazon Redshift Serverless Capacity and Serverless Process Provisioned. So Redshift has two versions. One is the original, which is Redshift regular version, or it is also called as Redshift Provision Mode or Redshift Managed version, in which you can see clusters and nodes. Then they came with serverless technology, and that version is known as Redshift Serverless, and I will be covering both the versions of Redshift in this lecture. I will be explicitly calling out when I am talking about provision mode or the serverless mode. So what is Amazon Redshift? Amazon Redshift is a cloud-based, fully managed data warehouse service designed for petabyte scale analytics. It caters to organizations dealing with massive amounts of data, providing a robust solution for large-scale data processing and analysis. Amazon Redshift offers a serverless option called Amazon Redshift Serverless. This feature automatically provisions resources and scales data warehouse capacity to meet performance demands for unpredictable workloads. It adapts to changing data processing needs without manual intervention. The serverless model adopts a pay-per-use pricing structure, charging only for active usage. This eliminates the need for upfront cost and allows business to pay only for the resources they consume, making it a cost-effective solution for varying workloads. The service supports immediate data loading and querying through Amazon Redshift Query Editor v2 or compatible business intelligence tools. It maintains fast query performance across datasets of all sizes, utilizing familiar SQL-based tools and applications, making it accessible to users with SQL knowledge. A key feature of Amazon Redshift is its ability to securely access, combine, and share data from various sources. These include operational data stores, data lakes, streaming services, and third-party datasets, all with minimal data movement. This capability enables comprehensive data analysis from diverse sources. The service is deeply integrated with other AWS services like AWS databases, analytics, and machine learning services. This integration enables zero ETL approaches, near real-time analytics, SQL-based machine learning model building, and Apache Spark analytics using Redshift data, providing a comprehensive ecosystem for data processing and analysis. Amazon Redshift Serverless caters to engineers, developers, data scientists, and analysts by providing an easily scalable zero administration environment for analytics. This reduces the operational overhead and allows users to focus on data analysis rather than infrastructure management. The service employs a massively parallel processing MPP engine and separates compute and storage for efficient scaling. This architecture allows for high performance and scalability, enabling the processing of large datasets quickly and efficiently. Amazon Redshift incorporates machine learning driven performance innovations such as auto-materialized views. These features optimize query performance automatically, reducing the need for manual tuning and improving overall system efficiency. These features contribute to Amazon Redshift's scalability and its ability to deliver up to 5 times better price for performance compared to other cloud data warehouses, and this makes it a cost-effective solution for organizations looking to maximize their data analytics capabilities while minimizing cost. Now, I will be just covering specific points related to serverless. So Amazon Redshift Serverless adjusts capacity in seconds, ensuring high performance consistently for even the most demanding and volatile workloads. Users can utilize workgroups and namespaces to organize compute resources and data. This feature provides granular cost controls, which allows for better resource management and cost optimization. So I will be covering workgroups and namespaces in the upcoming slides. Users can interact with Amazon Redshift Serverless through a console interface to reach the serverless data warehouse or use APIs to build applications. Through the data warehouse, user can access Amazon Redshift Managed Storage and Amazon S3 Data Lake. providing a comprehensive data analytics solution. Okay, next, so now I'll be going into the technology side of it, the provision clusters, the Amazon Redshift overview of the provision clusters. An Amazon Redshift cluster is a set of nodes which consist of a leader node and one or more compute nodes. The type and number of compute nodes that you need depends on the size of your data, the number of queries you will run, and the query runtime performance that you need. Depending on your data warehousing needs, you can start with a small single node cluster and easily scale up to a larger multi-node cluster as your requirements change. You can add or remove compute nodes to the cluster without any interruption to the service. Reserving compute nodes. If you intend to keep your cluster running for a year or longer, you can save money by reserving compute nodes for a 1 year or 3 year period. Reserving compute node offers significant savings compared to hourly rates that you pay when you provision compute nodes on demand. Creating cluster snapshots. Snapshots are point-in-time backups of a cluster. There are two types of snapshots, automated and manual. Amazon Redshift stores these snapshots internally in Amazon S3 by using an encrypted secure socket layer SSL connection. If you need to restore from a snapshot, Amazon Redshift creates a new cluster and imports data from the snapshot that you specify. Cluster access and security. There are several features related to cluster access and security in Amazon Redshift. These features help you control access to your cluster, define connectivity rules, and encrypt data and connections. These features are in addition to features related to database access and security. AWS accounts and IAM credentials. By default, an Amazon Redshift cluster is only accessible to the AWS account that creates the cluster. The cluster is locked down so that no one else has access. Within your AWS account, you can use the AWS Identity and Access Management IAM service to create user accounts and manage permissions for those accounts to control cluster operations. Security groups. By default, any cluster that you create is closed to everyone. IAM credentials only control access to Amazon Redshift API related resources, Amazon Redshift console, command line interface, API and SDK. To enable access to the cluster from SQL client tools via JDBC or ADBC, you will use security groups. If you are using EC2 VPC platform for your Amazon Redshift cluster, you must use VPC security groups, and it is recommended that you launch your cluster in a EC2 VPC platform. Encryption. When you provision the cluster, you can optionally choose to encrypt the cluster for additional security. When you enable encryption, Amazon Redshift stores all data in user created tables in an encrypted format. You can use AWS Key Management Service (KMS) to manage your Amazon Redshift encryption keys. Encryption is an immutable property of the cluster. The only way to switch from an encrypted cluster to a cluster that is not encrypted is to unload the data and reload it to a new cluster. Encryption applies to the cluster and any backups. When you restore a cluster from an encrypted snapshot, the new cluster is encrypted as well. Okay, now Amazon Redshift Provision Cluster Database. So this is a high level view about the database only. So a database, a cluster contains one or more databases. So this is whole. In a single cluster, you can have one database or multiple databases. User data is stored in one or more databases on the compute nodes. Your SQL client communicates with the leader node, which in turn coordinates running queries with the compute nodes. Within a database, user data is organized into one or more schemas. So Amazon Redshift is a relational database management system, and it is compatible with other RDBMS applications, and it provides the same functionality as a typical RDBMS, including online transaction processing, OLTP functions such as inserting and deleting data. Amazon Redshift is also optimized for high performance batch analysis and reporting of datasets. And coming to serverless, the key concepts are, first one, namespace. So namespaces, which is a collection of database objects and users. Namespaces groups together all of the resources that you use in Amazon Redshift serverless, such as schemas, tables, users, data shares and snapshots. Coming to work group. A work group is a collection of compute resources. A work group house compute resources that Amazon Redshift serverless use to run computational tasks. Some example of such resources include Amazon Redshift Processing Unit (RPUs), security groups, usage limits. Work groups have network and security settings that you can configure using the Amazon Redshift serverless console, and the CLI and the APIs. So these are all the network settings that you can configure. Okay, now let's understand about the Amazon Redshift serverless capacity (RPUs). So Redshift serverless measures data warehouse capacity in something called as Redshift processing units (RPUs), and these are the resources to handle workloads. So the base capacity, this setting specifies the base data warehouse capacity which Redshift uses to serve queries. Base capacity is specified in RPUs, and one RPU provides 16 GB of memory, and the default base capacity starts default means if you don't specify, it will be 182 RPUs. So you can so the total memory comes to 16 GB into 128 into 16 GB. So that will be total amount memory if you don't change any setting. But you can adjust this range. It starts at 8 RPUs and it goes all the way to 512 RPUs, and in the increment of 8. So 8, 16, 24, 32 like that. Higher base capacity improves query performance, especially for resource intensive data processing jobs. So flexibility for different workloads. So minimum, as I talked about, 8 RPUs, then increment of 8, and that goes up to which you have data up to 128 terabyte of data it can handle. Then after 32 RPU or more, this is required for data requirements that is greater than 128. So if your data crosses 128 or more, 128 greater than 128, then you have to go, it starts with 32 RPU or take more. So this is recommended for workloads with table having large number of columns and higher concurrency. So you can opt for 32 or more, even in case wherein you have high number of columns and higher concurrency requirements. Some consideration and limits. So storage capacity limits. So 8 or 16 RPU configuration up to 128. Then after 128, you have to minimum 32 is required. And query impact. So editing work group space capacity might cancel some running queries. So this is important because usually a data warehouse is a highly used system. So you have to plan ahead. So if you are modifying it in the middle, it will impact the actual production users or some analytical workloads. Okay, now this will be a feature comparison between serverless and provisioned version. So first one, work group and namespaces. This is part of serverless. So you use namespaces for database objects and users, and work groups for compute resources. In case of provision, we use clusters with compute nodes and a leader node. Node types, it's automatically managed because it's a serverless version, but you can specify the base capacity as we have seen. For provisioned, user chooses node types and count. Workload management, it automatically scales based on workloads. Provision, concurrency scaling enabled manually, so it's done manually. Port number 5431 to 5455 or 8191 to 8215. For provision, you can choose any port. Resizing, it's not applicable, but you can change the base RPU capacity. For provisioned, it's manual cluster resize. Pausing and resuming, not needed, pay only when queries run, but in provision, manual pause and resume. Spectrum queries, Redshift Spectrum, this is it will query Redshift plus S3 together. So build when compute resources process workloads. There is separate spectrum capacity for provision mode. Compute resource billing is per second and 60 seconds is minimum. Per second when not paused. Maintenance window, no window, updates handled seamlessly. User chosen recurring time. For encryption, always encrypted with AWS KMS. Optional encryption. Storage billing, it's billed GB per month storage, and provision, it's separate for compute for RA3 nodes because the data is stored in RA3 nodes, so you will be charged for those nodes hours, not by the storage directly. User management, IAM or Redshift users, both IAM or Redshift users. Compatibility, JDBC or DBC compatibility, both are compatible. Credentials on sign-in, it's not required every instance. In the provision, it's required for each sign-in. Data API supports, it uses workgroup name parameter. This supports user cluster identity parameter. Snapshots, supports snapshots and recovery points. For provision, it only supports snapshots. Data sharing supports all features including cross type, and provision supports cross database, cross account, cross region sharing. Tracks, this is for CloudTrail, no concept of tracks, supports current and trailing tracks. System tables and views, supports new tables and views. This supports existing set. Parameter groups, no concept of parameter groups. This supports parameter groups. It's similar way to like to consolidate the different configuration. Query monitoring requires database connection in sync with system tables. May not show all data in the system tables. Audit logging, CloudWatch destination, no S3 support. For provision, S3 and CloudWatch both supported. Event notification, this uses Amazon Event Bridge. This one is managed through Redshift console. And that's all. Thanks for watching.